Hello, and welcome to an introduction to U substitution. Today we'll cover 3 different questions, as this is a short introductory video. Our first question is the integration of 5 plus the ln of x raised to the 5th power all over x. Now, one way to know that we can use U substitution is by looking at the problem and realizing that we don't have a basic integration rule for this setup. But if we dig a little deeper, we can see that we have a function that is differentiable here, 5 plus ln of x. So once we have picked a u value, we need to find the first derivative of it, which in this case would be 1 over x. Now, we know that constants, the first derivative of a constant is 0, and the first derivative of a natural logarithm is value over its derivative. So for x would be 1 over x. As we look at the problem, we can see that what we really have is 1 over x, which is our du value being multiplied by 5 plus ln of x raised to the 5th power, which in here is our u value. So then this becomes the integration of u to the 5th du. Now, we have a basic integration rule that we can apply to this, which is a power rule, giving us u to the 6th over 6 plus c. Now, we're not quite done, but we've gotten from something that we didn't have an integration rule to having it integrated. Now, all we have to do is take our u value that we had picked before and plug it back into the formula so we can complete the integration. So then this then becomes 5 plus ln of x raised to the 6th power all over 6 plus c. Now, for our next question, we're going to look at something a little more complex, but not by much. Next, we will do the integration of 4 secant of 4x times the tangent of 4x times the secant raised to the 4th power of 4x. Now this looks a little long and a little scary, but if we simply look at what we have, we can pick out our u value. The only part that we have raised to a power is 1 secant raised to the 4th power. When we look closely, we see that we have a first derivative of a secant function. All we have to make sure is that it correlates, because we have a 4x value and we have a 4 in front, so we should be okay. But let's just check. We have the u value being secant of 4x. Then the derivative of that would be 4 times secant of 4x times the tangent of 4x. Because the derivative of a secant would be the derivative of the angle times the secant of the angle times the tangent of the angle. Okay? So now we come here, we see that this big lump is just simply our du value, and in here we have u raised to the 4th. So then this big problem simply becomes u to the fourth du, which again, we can use a power rule, simplify that down to u to the fifth over 5 plus c. Now the last thing we have to do is take our u function and place it back in here, giving us the secant of 4x raised to the fifth over 5 plus c. And that is our answer. Now we're going to do one more question. As you may have noticed, we haven't really had to do any rearranging to get to our du function, but math isn't always so neat and clean. So our last question is going to be the integration of the square root of 7x plus 9 dx. Now you may look at this and think to yourself, well, we really don't have a value that can take the place of our du value. But with a little bit of algebra, we'll get there. For now, let's just say that 7x plus 9 is going to be our u value. So let's find the derivative of 7x plus 9, which the derivative of constant is 0. And using the constant multiple and power rule, we get that our du equals 7. Now luckily 7 is a constant, so we don't really need to see it in here to be able to use this. What we do is just divide both sides of this by 7. So we have that du divided by 7 equals our dx value. And then we carry out a 1 over 7 outside of our integrand. And what we're left with is the square root of u du. So we had to do a little bit of algebraic manipulation to get to see everything clearly, but again, it was a simple process. Now, this then becomes u to the 1/2 du, which, when we apply the power rule, becomes u to the 3/2 times 2 over 3. Let's see. Now the final step, again, we have to take our u function, plug it in. So we have 2 times 7x plus 9 to the 3/2 power all over 3 plus c.